Hey everyone! Welcome back to BugNoJutsu, the place where we break down tricky LeetCode problems and make them super easy to understand. Today, we're tackling LeetCode 2785, sort vowels in a string. This is a medium difficulty problem, and it's a great mix of string manipulation and sorting logic. If you're preparing for interviews or looking to strengthen your problem-solving skills, this one is perfect for you. So, grab your notes, because we're going to analyze the problem step by step, look at examples, and understand an optimized solution that's both clean and efficient. The problem statement is straightforward but requires careful attention to detail. You're given a zero-indexed string S, and your task is to rearrange it into a new string T by sorting only the vowels, while leaving all the consonants in their original positions. Let's break that down. Vowels are defined as a, E, I, O, U, and this includes both lowercase and uppercase letters. Consonants are every other alphabetic character that's not a vowel. When you rearrange, you can only sort the vowels, consonants must stay exactly where they are. The sorting has to be in non-decreasing order of their ASCII values. That means if a vowel earlier in the string has a smaller ASCII value, it must appear before vowels with larger values. So, even though you're permuting the string, you're doing it selectively, sort vowels but keep consonants fixed. This makes it a fun problem because you can't just sort the whole string or extract everything, you have to carefully place vowels back into their proper positions. Let's walk through the example. Input, S equals LeetCode. First, identify the vowels, they're E, O, and E. The consonants are L, T, C, and D, and their positions must remain unchanged. Now, sort the vowels by ASCII value. Remember, uppercase letters like E, ASCII 69, come before lowercase letters like E, ASCII 101. After sorting, the vowels become E, O, E, E. Next, place these sorted vowels back into their original vowel positions. The string structure with placeholders, L, T, C, D, E. Fill in the vowels in order. E goes into the first vowel position, O next, followed by E and then E. The final result becomes ASCII. This matches the expected output and confirms that sorting vowels while preserving consonant positions works perfectly. The approach I used for solving this is clean and efficient. Step 1. Identify vowels. I first created a set containing all vowels, both uppercase and lowercase, for quick membership checking. This makes it easy to decide whether a character is a vowel or consonant in constant time. Step 2. Collect and sort vowels. I iterated through the string and picked out all vowels, then sorted them according to their ASCII values. This gives me the exact order in which they need to be placed back. Step 3. Replace vowels in order. Next, I converted the string into a list of characters, so it's mutable. Then, I traversed the list again. Every time I encountered a vowel, I replaced it with the next vowel from my sorted collection. Step 4. Reconstruct the string. Finally, I joined the updated list back into a string and returned the result. This method is simple because it separates the problem into two parts, extracting and sorting vowels, and then placing them back, which makes the logic very readable and avoids unnecessary complexity. Let's analyze performance. Time complexity. Extracting vowels takes O(n), where n is the length of the string. Sorting the vowels takes O(m log m), where m is the number of vowels. Replacing vowels back also takes O(n). Overall, the complexity is O(n plus m log m). Since m less than or equal to n, we can approximate this as O(n log n), in the worst case. Space complexity. We use extra space to store the vowels and the mutable list of characters. This is O(m plus n), which simplifies to O(n). This is efficient enough for the input constraints of the problem. This problem is a great example of two-pass string manipulation. A key insight is realizing that you don't need to overcomplicate things, just extract what needs sorting and leave the rest untouched. Using a set for vowel checking ensures constant time lookups. Also, sorting only the vowels instead of trying to manipulate the whole string reduces unnecessary overhead. Another takeaway is the importance of ASCII ordering. Many beginners forget that uppercase letters have smaller ASCII values than lowercase letters, which can lead to incorrect sorting. So always remember to test your solution with both uppercase and lowercase vowels. And that's it for today's problem. We just solved LeetCode 2785, sort vowels in a string in an efficient and straightforward way. If this explanation helped you, make sure to like, subscribe, and hit the notification bell so you don't miss out on future problem breakdowns here at BugNoJutsu. Also, drop a comment below sharing your solution or any optimizations you came up with. It's always great to learn from each other. Thanks for watching, and I'll catch you in the next video where we'll tackle another exciting coding challenge. Until then, keep practicing and keep that problem-solving streak alive.